I'll make sure I get the class recordings posted. This one might take a little bit of time. I should be able to get it up before I leave today, and in case it, if it gets lost in the ether where it isn't uploading to my Kaltura. Not that you guys care about that, how exactly it happens, but if it doesn't upload by the end of the day, I'll definitely upload it tomorrow morning. So you kind of have what we do today as a recording, right? So where are we at with the class? We currently kind of have is that quiz, which is due by the end of the day, Friday. So those practice problems for it are right here. That was before break, and then that class after where we were talking about nonlinearities. We also had that fourth problem set. I said I extend the due date a little bit. A couple people tried to stop at my office Wednesday. You'd see it was pretty hectic. If you do have still some questions on that and you want to meet tomorrow, I've got some student meetings. There'll be people kind of there throughout the day, but if you kind of stop by, you can kind of get in line. I'd be more than happy to kind of meet with you then. I should be there primarily between like 9:30 and like 1 if you want to stop by. Otherwise, Monday's office hours should be quite a bit less hectic. I would also always mention the morning ones are always less traffic than the afternoon ones. So if you're wanting to guarantee to kind of get your question answered there, or just have fewer people kind of around, that would be kind of what I would suggest. So I moved that due date though of that problem set, so that's before we meet in class on Tuesday. So a little bit extra time to work on that if you're still kind of working on that fourth problem set. I will tomorrow. Well, I don't want to have kind of concurrent things running, so I'll wait until after Tuesday's class so we kind of keep things separate. But the next problem set and the next quiz will be primarily over these interaction terms, but then there's also going to be a little bit of it over the next topic that we covered. So I'll get those posted after class Tuesday. We'll start the next topic, so you can kind of start working on those if you want to. We won't have covered completely everything to answer the last few questions probably. But that way, if I post it Tuesday, it's not kind of overlapping. We don't have any problem sets or quizzes overlapping to kind of get confused about. So you'll see those pop up Tuesday after class when we start that next topic. Okay, it's primarily related to kind of measurement error. That's what we'll be talking about. So today, unless there's any questions, just the logistics or anything you wanted to kind of see review, I try to go a little bit slower through the topics in the second half of the class. So reserved kind of time in class, if you have questions, is a good time to ask. We went through things a little bit quicker because I feel like I'm not getting as many questions as I maybe expected as we're going through this interaction stuff. Having another example, maybe some of those will pop up, but by all means, always feel free to stop me, any clarification, or kind of want something me to kind of restate something or say it in a slightly different way. Okay. Any questions from me before we jump into it here? All right. So we will kind of start with this election data file. So I think here I've actually got it in an old folder. So let's go ahead, go to File, Open. I've got my. Did I not drag and drop it in here correctly? Well, that would be a problem. Luckily, so I think this is sitting on my computer. So let's say here. I should have it still sitting here, which is. Oh, did I give it to you as an Excel file? Yes, I did. Thank you. Sorry. Thank you for saying that. I don't know why I didn't do. I have an Excel file here. So this goes back. I can't open it. It's not a Stata file yet. I'm going to import it. I think it's an Excel file. Now I should have it sitting there. Yeah. So it is sitting on my OneDrive. I thought I could have sworn I moved it. So this is where if we don't have something that starts out as a Stata file, we have to import it. Actually, I think I mentioned this last class when I asked you kind of about data sets that interest you. You can always go out there and find data. In fact, if we have a little bit of time today, I'll maybe kind of show you what this looks like. If you have anything that interests you, kind of how you build your own data set, and then can kind of upload that into Stata and kind of run your own regressions if you're interested in things. So in fact, I believe, so I'll open this up, but I now recall, and here I've got my first row is my variable names. So I'm going to, I can hit OK here. There we go. I believe what I did, so I'll kind of give you a little bit of a sneak peek. If I'm ever interested in something, this is a little bit like less, I'm not going to quiz you or test you on this, but this is just more life or work practical. So actually the other day, what was I interested in? Well, we can do the election one. So all I'm going to do is just search election results, 2020 data. In fact, maybe I'll specify presidential. So sometimes you'll have some things pop up here. They don't look like, well, these aren't like data. These are New York Times. Oh, well, here's something that maybe looks like it might have an actual data file. Oh, okay. I can start to click on some of these things. Here's like county level results for the Senate race of 2022. Sure enough, they've kind of got, okay, well, these aren't files that I can use. So I might want to go back. Okay, that's not going to work for me. So maybe what can I specify? Excel, right? Because I know how to import Excel into Stata. So I come down here, oh, the American Presidency Project here, select on 2024. Scroll down here. Okay, well, I've got state level data. It doesn't always come in a nice, easy form. Maybe it's not in Excel, but what can I always do from a web page? I can actually highlight this, copy it, and always just paste it into Excel, right? So I do that a lot. In fact, oh, how many of you, anybody interested in any type of sports? Basketball, football, couple. So let me see if I can remember. Sports reference. In fact, this has like hockey, college football, soccer, anything that you would want. You can kind of come down here. I'm going to look at clubs. They've got a bunch of different data here. So what do I want? Well, I can actually look at competition. Let's do that. Kind of see here, I can select different competitions. This doesn't take super long. Maybe 2024. Taking longer than I had expected. So we're waiting. So you've got some different results here. Maybe I'm not as familiar with the soccer one. Maybe this is let's go to the basketball one. So I know where I can find this one. So here we've got like schedule and results. Kind of gives me this option. I can export it as an Excel file. I can then use all this data. I could do this by, looks like it's got like win share percentage, all kinds of different statistics. So honestly, anything you're really interested in, like I said, you can just start to do some of these Google searches, and a lot of the times you can find something that's going to be, at least in some way, something you can copy and paste into Excel, some type of an Excel format. I think the other one, let's do, what was a good one? This would be like, what do I want? Let's do Indiana University tuition cross time. Actually, I know what we can do. University tuition data Excel. You can then start to kind of find, well, looks like maybe I've got something here. I can I'm not going to download this because I'm not exactly sure. I don't know I don't know the virus, but like you just by Google searching, you can find a lot of these data sets that exist. And as long as you have it in Excel, you can upload it here in Stata. We can start working with it. So that's, like I said, I forget the exact source, but that's how I found this election data. It was just laying around out there on some website. It was some government website where they kind of had the reported amounts. And I believe if I look at this, it's not only by state, but it's by county. Right? So I've got county level data. This is from the 2020 election. So not the most recent. So maybe I would want to kind of try to go out and find 2024 results. I could do a very similar thing. So go here. I've got a variable that existed, which was the %20 Donald Trump. That's what it was called. I didn't name these variables. Sometimes when you download data, they've got some nasty kind of names. So here was what? Trump and Biden. So notice, even though it says it's percentage, what form is this data in? 0.59, 0.66. This is actually telling me the proportion. So you know, just to kind of line up a little bit more, I'm going to create a new variable where I multiplied that by 100 just so it makes it actually the percentage, and it makes it a little bit easier when we start to do some of these interpretations, okay? So I'm going to create this new variable, which is just the percent of people that voted for Trump in 2020. So maybe I was trying to predict election results of what I thought I might see in 2024, okay? So I'm going to create that variable. All right, we can see that it's doing that. I'm then also going to scale income. Now, I say to make it easier here, it makes my interpretations a little bit different, but we want to get used to being able to interpret variables that have different scales. Instead of looking at these insanely large numbers, I'm going to scale this by 1,000, right? So an average income of 50,000 in a county will show up as 50, right? Just dividing that by 1,000. So here I'm going to look at my income variable, 62,000. This new variable I created that now becomes 62. Okay, so we'll kind of keep running with that. I'm then going to start to think about interaction terms. Okay, so I had this idea. Okay, I can control for the proportion of these counties that were male, different demographics. I also am then going to control for what the total population was. So maybe, you know, I might think there's different voting habits depending on if it's an inner city or a large county or a rural county, right? That total population should kind of capture some of that. So what I'm going to do is kind of include this interaction where I've got two continuous variables. This is kind of the examples we left off last class. I'll kind of give you another one. Now, before we do that, we can also look at an interaction with a continuous and a dummy variable. So I'm going to look in this data set, and I'm like, okay, I want to somehow identify, is this a rural county or not? It doesn't look like I have a variable that's really going to identify that. But what could I do, right? So I'm going to create kind of a low population variable. And I'm going to think about, okay, I know that rural versus metro counties, the rural counties are going to be quite a bit lower in population. So I'm going to say I want to create this new variable that's equal to a 1 if that total population in the county is less than a certain amount. Now, I don't know exactly what amount I want to choose. I would probably go to like, oh, the Census Bureau or something like that. They probably have some definition of what defines a metro versus a rural county. In fact, if I was interested, so I could probably do a quick Google search. All right. Looks like maybe they're not going to give me kind of a hard and fast. Oh, okay. Looks like, all right, 5,000. All right. That would be kind of at least what defines urban. So I'm just going to say if my total population is less than 5,000. Okay. So that's going to identify these really rural counties. Right. So I'm going to create that variable. I'm then going to say, I want to run this regression that I had outlined here below. But instead of this interaction of income and unemployment, which we'll look at here in a second, I'm going to think about, all right, how will counties vote differently if they are rural or these low population counties? Okay. And then maybe I'm interested, okay, how does that interact with what the total kind of income value is in those counties? So even if it's a rural county, if the average, or a really small county, I should say here, if the average income is really high, maybe they tend to be a little more likely to vote for the Democratic candidate or Republican, you know, vice versa, right? Whatever it is. So anytime I want to include an interaction between a dummy and a continuous variable, I don't have to do anything with this dummy variable, but I have to identify this is a continuous variable, right? This income variable that I created, which I scaled to be 1,000, that's continuous. Okay? So I'm going to go ahead and run this regression and then look at my results here. Oh, what did I do? Did I not create this variable yet? Tot pop, did I call it something differently? Oh, yes. Total population, right? So here I'll create that low pop variable, run my regression. Okay. So I get these regression results where I've got the impact of being in a low population county. So once again, I'm kind of just going through things we've already talked about, but we'll kind of rehash this. So I've got my results now, and I've got other controls, but what I'm primarily focused on is what's the percent of that county that voted for Trump? And I'm thinking about, I've got whether or not it was this low population county. I've got what the income level was, and remember this was in thousands. And then we just ran a regression where I also included an interaction of those two. Okay. So this is where sometimes drawing it out might kind of help me think about what I'm doing. So if I'm interested in what's that relationship between income in a county and the percent of that county that voted for Trump, I might have my preconceived notions of what I might think it might be, but here I can actually explore it, right? So we're going to have a line of best fit, but anytime I have an interaction term, what am I allowing for here? My line of best fit between the 0 and the 1 group, by including the interaction, I'm allowing that to do what? So let's think about this, right? If I had a low population county, right, versus a high population county, where would the high populations county line of best fit start out at? So if I'm trying to predict Y, if income is 0, where would the high population county start? Yeah, so not necessarily a specific value, right? But if it's a high population, this would be 0, this would be 0. The only thing left is beta 0, right? Which you just told me the number. I've got it here. Looks like it's 43.56. Right, so I'm going to kind of put this here, 43.56. Okay. Now, if I then think about what's the effect if income goes up by 1 unit. Now here, income going up by 1 unit is actually income going up by what? $1,000. So if the average income goes up by $1,000, that would be a 1 unit change. How much is the predicted Y going up by? Well, if it's a high population county, right, what would the slope be? This would be 0. This goes away, right? So what am I left with? The effect of a 1 unit change in income would be simply beta 2, right? So here's kind of my slope. Here was my intercept for the 0 group, right? So beta 2 in our example is negative 0.3. So if I'm doing my line of best fit here, that slope, beta 2, is negative approximately 0.3. We could go out 304 or whatever decimal we were interested in. Everybody with me up to that point? Okay, so what if I want to do the low population county? Where's their intercept going to start out at?
So beta 0, and then since low population reference going, it would be beta 0 plus beta 1.
Yep. So this would be what? 43.56. And if we go back to our regression results, which we'll hop to in a second, it looks like that beta 1 is negative 12.79. So to be clear, I'm adding in that coefficient, but it's negative, so that's why I have a minus here. So that's going to be what? Approximately 31-ish, right? So what? 30? No. Yeah, about 31, right? We'll kind of do some egregious rounding here just for the sake of not getting too lost in the decimals, right? So here, by including this interaction term with a dummy variable, I've allowed my line of best fit to start out at a different point. Now, what is the slope of a 1, or what's the kind of marginal effect of a 1 unit change in income going to be for these low population counties? It's not only going to be beta 2, which before we had was negative 0.3. It's going to be beta 2, but when low population is 1, it would also include beta 3. So beta 3 here I've got is 0.44. So that would be what? Negative 0.3 plus 0.44 would give me approximately 0.14. This is kind of an extreme case, and it's kind of interesting here that, okay, when I had these high population counties, so these were, thinking about these as like cities, right? They start out actually with a higher percent of them innately going to vote for Trump. However, as the income was higher in those counties, what did they tend to do? Be less likely to vote for Trump. So when we have some of these like high population areas, but with low income, those counties tend to vote pretty high percentages for Trump. These really wealthy counties in larger areas, who do they tend to vote for? The Democratic candidate of Biden. Right? Now, what's interesting is for our low population counties, so these are, I'm thinking of rural counties, but it could probably technically some of the counties surrounding Bloomington, we would consider these low population counties. They initially start out when income is really low, a lower proportion of them actually vote for Trump. However, in these rural counties, low population counties, as the income starts to go up in those counties, what do they tend to do? They actually had a slope of positive 0.14. They actually become, so this is beta 2 plus beta 3, more likely to vote for Trump. Right? You know, I'm no political economy expert, although I know a little bit, but I'm no, you know, I'm not in the world of politics. But you know, I imagine there's some story there about large cities when they're kind of wealthier, right? They tend to be, you know, the candidate that's going to give them a couple more tax break, or it might be a little bit more kind of lining up with some of the things they think, might tend to be the Democratic candidate. When you're in rural counties and you have more income, why do you think you have more income? Well, it was because this, you know, the Republican candidate was kind of helping out my county, right? I don't know exactly what is driving this, but this is a really interesting example because not only do we have a significant difference in our intercepts, we also have a pretty significant difference, not only difference in the slopes are completely opposite signs. So if I'm on either side of the aisle and I'm thinking about what counties do I want to target, if I'm thinking about high population counties and I'm the Republican, or if I'm the Republican candidate and I'm thinking about, well, who do I want to target here? High income counties that are low population, I don't really have to worry about them. Or sorry, yeah, I don't have to worry about them. I think they're going to vote for me. But high income counties that are high in population, I know they're less likely to vote for me. Maybe I want to kind of send my efforts towards them, right? I need to win more of them over, right? And then kind of the exact opposite if I was the Democratic candidate. Yeah.
So what would happen?
So when we take derivatives, we never take them in respect to the coefficients. We're only going to take these in respect to the variables. That's really what we were doing here, right? So if I want to know what's the marginal effect of income here, that's what we have graphed out. Well, that marginal effect, if I take a derivative in respect to income, what am I going to be left with? Beta 2 plus beta 3 times low population. So my marginal effect depends on if it's a low population county or not. Well, here's where, unlike when we had continuous interactions, there's only going to be two marginal effects. One for my zero group and one for my one group, right? For the zero group, it would simply be beta 2. And for the one group, it would be beta 2 plus beta 3, which is how that was just, what did the marginal effect represent? It simply represents our slope. Yep. Okay. So taking a derivative of our regression to determine what the marginal effect is a different way of thinking about our slope. Okay. All right. Any questions here before we keep moving? So if I'm interested in the kind of income level where maybe these marginal effects cross, how could I find what that value is? Well, here, if I want to know, this isn't the marginal effect, sorry. If I want to know where that predicted, right? Where does a low population county start to have a higher predicted probability for voting Trump than a low population county? Well, I'm really looking for where these two lines of best fit would cross. Okay? So for the low population county here, and then we have our high pop, if I'm coming up with predicted values for Y, or the predicted percent of people who are going to vote for Trump, that would be equal to, well, we said the intercept for my low population was beta 0 plus beta 1. And then plus, what is my slope associated with income? Beta 2 plus beta 3 times income. I guess I'll stack these since I kind of ran out of myself out of room there a little bit. What's the predicted Y value or the percent that are going to vote for Trump from a high population county? Well, there we said their intercept was simply beta 0, and the slope was simply beta 2. Right? So what am I going to do? If I can get this unstuck, I'm going to set these two lines of best fit, or really what these were predicted Y values. I'm going to set them equal and see where do they cross, right? So here I'd have what? Beta 0, and I could plug the numbers in here, but I'm going to do this just with general terms to kind of show you what we would end up with. Instead of income, if we wanted to, you could think about this as an X variable. So here we've got income, but we could do it more in general. This is just some X variable. Well, notice if I subtract beta 0 from both sides, this cancels. If I subtract beta 2 times income from both sides, this would cancel. So I'm left with beta 1 plus beta 3 times income, or whatever that X variable is that we interacted with, is equal to 0. So if a turning point exists where the predicted Y values cross, it will be, if I kind of rearrange this a little bit, that income value would be negative what? Beta 1 over beta 3. So the only way that that income value would be positive is if these two coefficients have what? Different signs, right? If they had the same sign, we might end up with something like where, yeah, maybe they start out at different points, but if they're both positive, they might never cross, right? Or vice versa, whoever we're looking at, okay? So here, what was beta 1? We said this was, no, I already forgot. There we go. Negative 12.79. Nope. Here, negative 12.79. What was the interaction term? Beta 3.44. This would tell me the income level at which these two cross. Right? So if I do this just real quick, someone has a calculator, you can help me out before I pull up, if you can get it pulled up before I pull up Excel here. 29. Yeah, so let's do what? Negative 12.79 over 0.44, was it? Oh. Negative 12.79 over 0.44. So I forgot my negative sign out front. So 29.06. So what point would kind of those predictions start to be higher for our low population counties? Anything after 29 would mean any income level after 29,000. So am I ever going to actually see, I don't know if there is a county with an average income of less than 29,000. I hope not, right? So in practice, we're probably only going to be seeing counties out here, right? Most counties are going to have an average income above 29,000. In fact, we could check to see if there are any counties. So just to kind of, I don't know, start to get your brains thinking about what we're doing here with the data set. What's one way we talked about in state of, how could I check to see if there was a county that had average income less than that 29 cutoff? What's a command I could use? If I want to get a quick summary, I just use the sum command. That's going to tell me the minimum. Oh, there are some counties that have less than 29,000 as the average income, right? Now, and I think the way the income came in here, I think they tied it to a certain year, so they probably adjusted for inflation. So are they actually making 29 or 19,000 here? Probably not. It's probably adjusted to a base level that's kind of previous in time. But still, there are going to be some counties that would meet that criteria, right? They'd be below that threshold of 29,000. Okay. Any questions there? So I'm just trying to take another example of something we've talked about and kind of taking a look at it here. Does that help confuse you? Any comments, questions? We're just here today. Okay. So I think hopefully, you know, when you're working through these, I really do think writing out these regression equations, trying to come up with a visual, and then also thinking about kind of like what these marginal effects are, differences between the 0 and the 1 group, that's going to help out when you have these interaction terms. Okay. Yeah.
So it's continuous. So many, like numbers.
Yeah. So let's think about the next one. Let's say I've got a similar setup. And here I'm interested in income, but I'm actually, let me make sure this is what I did. I think I did income unemployment. That's what I have in the do file, just so we line up with what we're doing there. Yeah. So let's say I think, okay, if the average income is higher, that's great, but you know, income is based off of people who have a job, right? So if 50% of the county doesn't have a job, it doesn't matter if the average income is high, right? So here I'm going to include an interaction term between income and employment. In fact, I'm talking, not thinking about what I'm doing. We'll first include income. We're now going to include this additional control of unemployment, and we think there might be some interaction between these two things. That the effect of income on the percent of people in that county voting for Trump will depend on whether or not a higher or lower percent of that county was unemployed as well. It doesn't matter if income is higher. If we have a high level of unemployment, that's not going to impact as many people in that county. So I've now got two continuous variables, okay? So here's where kind of drawing this out, it's a little bit more problematic. It's kind of difficult to do, right? Now, I can do it, but technically if I have two continuous variables, I would actually need like a three-dimensional graph, right, to kind of show what these are. And so here's where we kind of rely more on derivatives to think about, okay, what would the marginal effect of a 1-unit change in income be here? We don't have 0-1 groups anymore, right? So here, if I want the marginal effect of income, whatever I've interacted it with, that is what its marginal effect will depend on. So when I write this out, unemployment should be somewhere in my marginal effect. Just like if I want to find the marginal effect instead of unemployment on the percent of people in the county voting for Trump, well, I've interacted unemployment with income. My marginal effect of unemployment should depend on income, right? They'll depend on each other. So if I want the marginal effect of income, this is where we want to think about, I'm taking a derivative of this function in respect to the thing I want the marginal effect of. Now, if it helps, if you can look at this and say, oh yeah, if income goes up here, it also goes up here, it would change by beta 1 and then beta 3 times unemployment. If that's how you can think, easier to think about that way, you can do that, right? It would be, okay, the marginal effect of income would be beta 1 plus beta 3 times unemployment. But what really is this? It's the derivative of our regression in respect to that thing that we want to know the marginal effect of, the thing that's changing, okay? So another way of saying this is like the change in the percent of people voting for Trump from a change in income. That's the derivative we were taking. Is that any questions on that idea? Okay. So this is my marginal effect, right? What if I wanted the marginal effect of unemployment? What would that be here? Well, if unemployment goes up by 1 unit, I would have what? Beta 2 plus beta 3 times the variable I interacted it with, which was income. So we're going to actually run this regression. We're going to get these results and then think about kind of what that's telling us, okay? So here, if I instead want to run I can spell continuous interaction with income and unemployment. So I have to identify both of these are continuous variables. Okay. Now, I said last class, we can do it this way. I'm going to show you a way that I would personally do this, because when I start to include these interactions, I've got C dots in front of things. I kind of forget. The interaction is C dot this. Oh yeah, there's still a hashtag in there if I want to like reference these variables. So a lot of the times what I'll do, instead of using the shortcut, I'm going to create my new variable that just is the interaction between these two variables. Right? And I'll show you why this makes it a little bit easier, hopefully here in a second. I'm then going to run that same regression. I'm going to include an income unemployment, but then also the interaction of the two. So it's just a different way of doing the exact same thing. Okay? So the reason why I'm going to do it this way is because now if I'm looking, okay, what is my coefficient on income? Beta 1, it's negative 0.003. So we'll go back here. And actually, I might have forgot to say a zero. Let's see, what was it? 0.0003 negative, right? What was the coefficient on unemployment? Looks like it was negative 0.953 if I round to the second decimal. And then the interaction term, this is really small, 0.00. And actually, I'm already remembering why I did this in thousands. So let's see. What did I not do here? Let's change this to make this easier for us here in class today. So when I moved from the shortcut here, what did I forget? I was using the old income variable. So I'm going to drop that interaction that I created. And instead of using income, I'm going to use income in the thousands, just so my coefficients are a little bit larger and it's not as crazy when I'm looking at those coefficients, right? So we'll go ahead and run this. Now we get some coefficients that are a little bit larger. This is going to be a little bit easier for us to deal with, okay? So here now my beta 1 is negative 0.37, 0.95, and then the interaction is 0.006. So just making the values a little bit easier for us to work with in class. So here, my beta 1, after I scale that income variable, is now negative 3.7 approximately. This is still 0.953 because I didn't scale the unemployment variable. And then beta 3 now is 0.0068. So we'll just say 0.007 just for the sake of rounding here. Okay. And then 0.007, same beta 3, right? Same coefficient on the interaction term. So we've got that the marginal effect here of income, it starts out when unemployment is 0. What's the marginal effect? Negative. Having more income actually decreases the proportion of the people in that county that vote for Trump. As the unemployment rate is going up, what's happening to the marginal effect of additional income? It's getting closer to what value? Well, if this is going up, I'm adding in a positive value. This marginal effect of having more income in a county, it's actually getting closer to 0, right? So having more income, right? If my unemployment is higher, actually makes it more likely that that county was going to vote for Trump. So kind of weird, might kind of seem like it's counterintuitive there. But this is what the data is, right? This is what the data is telling us. Now, we could obviously include additional controls. We didn't have a huge, set of controls here. We had some. And then the same kind of idea. If income was really low, the effect of an increase in unemployment, it would actually make it less likely that people vote for Donald Trump or the incumbent in 2020. That kind of makes sense, right? If I have higher unemployment, less likely to vote for the person who's currently in power. Now that effect, as income is higher and higher in those counties, well, if income is high, people that are employed are going to be really happy. So, right, the fact that there's more unemployment, maybe that effect is getting closer to 0 as well as income is high. So this is how we would determine the marginal effects. We can grab those coefficients from our results, and then we can start to think about making predictions. What would the marginal effect of unemployment be for a county that had an average income of 50,000? Well, if we scaled this variable so that it was in thousands, what would the marginal effect of unemployment be for a county that had 50,000 on average in income? We would have beta 2 plus beta 3 times the average income was 50,000. So we already scaled it. This would be 50. And we could start to do this for any income level we were interested in. right? Now, to the point earlier, now I don't just have a 0, 1 group. The marginal effect would actually vary with every single possible value for unemployment. So I'm not going to like ask you to do all those, or we're not going to want to come up with all of those. Okay. All right. Any questions here before we go back to this data here? Okay. So I've got these results. I can start to think about there's some turning points, right? So anytime I have those coefficients not lining up, so in this case, in both marginal effects, one of them was positive, one was negative. So there is going to be a point where that marginal effect could go from being negative to positive, or the other one positive to negative. So what is that turning point going to be? Well, this is where we can use that display command, and we can just use the coefficients. So if I wanted to know the marginal effect of income here, if I want to know where does that switch from being negative to positive, what value for unemployment? Well, if my marginal effective income is this, what level of unemployment will this switch from being negative to positive? I would take that marginal effect and I would set it equal to 0, right? A little bit of algebra here. I come up with what? Unemployment. It's going to be equal to negative 0.37 over 0.007, right? Or remember, what did this represent? This was beta 1 over beta 3, or the coefficient associated with what I'm looking at the marginal effect of divided by the coefficient on the interaction term. So this beta 1, this was for the marginal effect of our first variable, which in our example was income. That's how we could find the turning point. What if we wanted to know the marginal effect of our second variable, which was unemployment? Well, here I've got the marginal effect of unemployment would be negative 0.53 plus 0.007 times income. So now I'm looking for what income level will the marginal effect of unemployment switch. So what do? Set this equal to 0. I get income will be equal to that turning point would be, negative, positive 0.95 over 0.007, or beta 2 over beta 3. So the turning point equation is essentially you'll take the coefficient of the variable that you were looking for the marginal effect of. You will then divide that by, in both instances, the coefficient on that interaction term between the two continuous variables. So you could go ahead and do that, figure out what these values are. Just kind of using a calculator, putting it into Excel, or kind of using this idea up here, right? So in fact, here, I don't think I want my negative sign. I was kind of copying and pasting this. Excuse me. Wait. No, I do want my negative sign there. My bad. And I should be clear here, actually, because I was writing this out. What did I actually end up with here? Beta 1 over beta 3. That's because I was moving this over. Thank you. So what did I actually end up with when I was finding this turning point? I wrote beta 1 over beta 3 here, but that's actually not quite correct, right? Because even though this was beta 1, when I moved it to the other side of the equation, what does the sign do? It flips. So I forgot to write, there's these negative signs in front. Okay. Is that clear? So I was just looking at the value. That is beta 1, but right, because I was moving it to the other side of the equation, there'll be a negative sign in front of it. So how can I do this in Stata? I can use the display command if this reads my fingerprint. There we go. And say, display to me whatever that ratio of the coefficient on the variable I'm interested in the marginal effect of. So here that I started out with unemployment, take that coefficient underscore B from the last regression of unemployment. Now this is where the reason why I created my own interaction term, if I didn't, so let's say I was using the other regression, I would have a similar thing, but this would be C dot income, C dot unemployment. It just, I have to remember there's a hashtag there. I'm using the C dots. You can do it that way. I just personally like to create my own variable because then I can make the name honestly shorter. And just I don't have to worry about all that. But you really can if you use that shortcut, and it lets you know like, oh yeah, here's the variable name you should be using. In fact, I shorthanded it here. Notice it's like unemployment and income 1,000. I would really need to use that entire thing. So this is why I like to create my own interaction variable, just because I can kind of type less. Really, that's the that's the end of the story there, right? So you can do it either way. Right? So we don't want to do it this way for now. So if I do that, I'm going to take the coefficient on unemployment divided by the coefficient on the interaction term, and it lets me know, okay, the marginal effect of unemployment switches over at an average income of 139,000. So is that marginal effect likely ever going to switch over from being negative to positive? No, right? So ultimately, higher unemployment is always going to have a negative marginal effect on the incumbent, right? That's not surprising. Now, what about the marginal effect of income? We could do a similar thing, use the coefficient on income. There's a negative sign out front, divided by the coefficient on the interaction term. Yeah. Oh, thank you, because I switched the, yep, we switched it to the scale version. Thank you. It'll make the numbers a little bit easier for us to look at. I kind of threw this together. This was something I didn't have before this semester, but I knew we had a whole class, so I tried to throw this together so we could get another example. So here, the marginal effect of income, when would it go from being, what started out as negative, when would it go from being negative to positive? If unemployment was above 54%, so are we likely ever going to see the marginal effect of income go from being negative to positive? No. So this is kind of a weird one. So as income goes up, these people were actually less likely to vote for the incumbent, which is kind of interesting to me. Maybe it's because, I don't know, wealthier people didn't like Trump because maybe he disrupted some of the, I don't know, ways they were making money, or maybe he was just unpredictable, right? And wealthy people like to be able to predict what's going to happen if we were talking about kind of their portfolio and things like that. But here we had the increase in income was never going to have a positive. I mean, it could theoretically have a positive effect if we can get a county that has more than half the people unemployed, right? Once again, we could check to see if that could ever be the case. I don't think there's a county, hopefully. Yeah, 28% was the highest, which is still, I would wonder what county that is because that's insanely high. But right, that's how we would kind of start to investigate these things. Okay. Got quite a bit of time left. There's something else. Oh, if I look at these results, so I've got a pretty good number of observations. So I'm reiterating this and hashing this out. Hopefully this is like easy questions once we get to the final, because there is almost no scenario where having more observations will lead you to lower statistical significance. When we're looking at our coefficients, even on interaction terms, having a higher sample size is always going to do what to our standard errors? Make them smaller, which would then do what to our test statistic? Increase it, which would do what to our p-value? Smaller, which makes it more likely we can reject. So 3,000 is a pretty good number of observations. Now here, can I go out and gather more information, more data? Well, I can't create counties in the US, right? So no, I'm stuck with the sample size that I have. Yeah.
So, well, looking at the interaction
Mm-hmm.
has a p-value, which is, I mean, it's just outside the range.
Yeah, so actually here, I would say that marginal effect of income and unemployment, does it actually vary? So does the marginal effect of income vary with the level of unemployment? At our statistically significant levels, what would I say? So remember, we always start out assuming that all these coefficients are equal to 0. So could I reject that interaction's coefficient is equal to 0? No. So I actually can't say that the marginal effect of income varies at all with unemployment. Well, I can't say it at our conventional levels, right? 90, 95. Now, what levels could I say it at? 75. It'll give me a p-value of what, 0.25. I'd just barely be over the threshold there. But yeah, this would be an example where my interaction term may not always be statistically significant, which this would indicate then, if I can't say that that's any different from 0, should I be including the interaction term? Not at our conventional levels, we would say we don't need to, right? Because it's not statistically significant. Yeah. It's a good question. Any other questions on that? Now, if we go back to our other example, this is a good question because I think I forgot to mention it back there, only because everything was like 0. Well, here, when we had the low population income interaction, there, should I be including the interaction in my regression? Well, its statistical significance is very high, basically has a p-value of 0. So yes, it looks like there is some statistically significant variation with the marginal effective income across low and high population counties. Now, instead of just making this a dummy variable, what's another regression I could run down here that would allow me not to just look at low versus high? I'm just going to copy this, so I'm going to spoil a little bit. Continuous, number 2, and not periods here. All right. So instead of using unemployment, that was statistically not significant. Right? Maybe I want to look at the interaction between total population and income. So I'm going to create my own interaction term. I'm going to then include income, total population, and I don't need a multiplication sign here. Total population times income. I could run a continuous. Now, I don't have to just identify whether or not the marginal effective income varies across low and high population counties. I can allow for that interaction to be continuous. I can allow for that interaction to change, moving all the way from 0 all the way up to whatever the largest size county is, right? So I could go ahead and do that. And what I see here is, oh yeah, that interaction term, sure enough, just like when I kind of forced it to be a dummy variable, that continuous interaction between population and income, it also is statistically significant. We don't have time to kind of use this example and dive in, but that's where really in practice, the only time you want to use a dummy continuous interaction is if the variable itself has to be a dummy variable. I use an example where I kind of forced, like I created a dummy variable based off of a continuous variable. It doesn't really make sense to do that. I could just use a continuous interaction. Now, if I have something like, oh, I don't know. I think the example I give you in the problem set, there's a used car data, and I have you interact if it's a manual or not with something in the next problem set. Well, it's either a manual or it's an automatic, right? There's no, that is a dumb, has to be a dummy variable. But in practice, if you are doing this, you wouldn't want to create a dummy variable to use interactions if it already starts out as continuous. You might as well just start out estimating a continuous interaction. Okay. Now, I would say, just to kind of give you, I'm hoping that some of the things you learn in this class will assist you in either a job you get or even in other courses. And so when I'm thinking about if I'm presenting regression results to people, I just said you might as well run a continuous interaction. You likely only want to do that if you're talking to other people who've taken 371 or understand data. If you're presenting this to the average population, it's harder to think about the marginal effective income varying with every level of population. It's much easier to tell them, here's the effect for low population counties versus high. So that might be a scenario where you do want to create this dummy variable based off a continuous variable because it's easier to convey, right, those results to a less than a group that is not as educated in data as you are, right? So I just want to be careful where I'm saying that. It's not you never want to do it. There's no reason why you can't. It's just that if you're talking with other people who understand this continuous interaction, there's no reason to force it to be a dummy variable. All right. The other thing I wanted to do, and this is going back to the previous one, so I'm going to make sure I run this regression again. Oops. So this is how we found our turning points. I'm going to come down here, and in fact, here's where using my own interaction term, actually, I can't do that when I'm trying to plot these marginal effects, okay? So I'm going to change this to line up with our example before. So we're using this income variable that we created in the thousands. So instead of income, I'm just going to use that income 1,000 variable. So I'm going to go back to using that shorthand or shortcut where it creates the interaction term for me. I'm going to run that regression. Now, what Stata can do if we use this command margins, right? We know that the marginal effect, we could calculate the marginal effect of income at every single unemployment level, right? It would just take a lot of time. Right? So what Stata can do is it says, okay, look, find the marginal effect of this variable. So dy dx, that's the derivative of y in respect to this x variable. That's our marginal effect. So look at the marginal effect of income that we scaled to 1,000 and calculate what the marginal effect would be at the variable that it was interacted with, unemployment, starting with 1, going up to 75. So if I'm going to kind of try to help you out here, and I'll post this after class with some edits. So beginning value, increments, the end value. The variable you want to find the marginal effect of. And the variable you interacted it with, right? So here, when we wanted the marginal effect of income, here's the variable I want to find the marginal effect of at different levels of the variable I interacted it with, starting with 1, going up in increments of 1 all the way to 75. Now, I'm going to actually, we said it was like 54. I'm going to just make this a little bit lower just so we don't have to wait as long. So if I run this command, it's going to give me the predicted marginal effect of income at every single level of unemployment. What level should this switch from negative to positive? We said it would be 54 point something, right? So from 54 to 55, we now see that marginal effect goes from being negative to positive. Same kind of idea. We could do the same thing, but the marginal effect of unemployment. Now here, because I scaled my variable, I'm going to start with just 0, right? I'm then going to go up in increments of 1. That would be 1,000 because we scaled it. And I want to go all the way up to, I don't know, $100,000. Okay. So if I go ahead and run this, it'll calculate the marginal effect of unemployment, but at various levels, the marginal effect of unemployment at various levels of income. Now, remember, these are 1,000, 2,000, et cetera. So we see here, it's always negative all the way up to $100,000. I forget, where did it switch over? It must be a really high amount. So what was it? Yeah, so let's do 150 instead of 100. We'll run that same command. Now we can see, where does that marginal effect switch? Oh yeah, looks like it was at 140 to 141,000. Yep. So this, saves us a lot of work by hand, right? And if I'm interested in the marginal effect at any income level, well, I can find it here pretty quickly. Okay. Any questions over kind of this idea of kind of using this margins command? We'll use it for some stuff later on in the semester, so I wanted to kind of introduce it here. There's not a whole lot more that we'll do with it at this point, but here's kind of me just introducing what that command is. We can start to look at marginal effects of any variable that we're interested in. Okay. All right. Are there any questions over anything that we've done, or what if this changed, or, and I'm looking, I'm walking through this, I'm trying to go slow, but to give you kind of just different variables, different examples of this, but it's really stuff that we've already talked about before today. Yeah.
Just to clarify, the interaction terms, they give us different intercept points with either dummy or continuous variables. But they also like, I'm just a little bit confused on the margin.
So we can't, once again, if I'm thinking about the marginal effective income, and I was graphing that out, its effect on here, the percent of people voting for Trump, right? At various levels of income, like before we could draw out, we weren't drawing out the marginal effect. We were drawing out, this is a good question. So when you go back to when you were interacting a dummy variable with a continuous variable, you can graph out and think about marginal effects because we're coming up with, this was a graph of what? The predicted Y values. So the slope of that predicted line of best fit, that told us our marginal effect. If we wanted to use predictions when we interact continuous variables, well, now I actually don't need just income. I would need a third axis. Oh, sorry. So when we're interacting dummy with continuous variables, we could think of the marginal effects. That was our slope. But the things we were actually drawing on this graph were our predicted Y values. If I want to do a continuous interaction, I need to know not only how income is impacting the percent of people who vote for Trump, now I need to know how does unemployment levels. So I don't have a two-dimensional graph. I actually now have 3 dimensions in which I need to make this prediction for the line of best fit. So when we draw these things out, when we draw out our line of best fit, we're always just selecting one independent variable. As soon as I have 2, to draw out what my predictions look like, it would be a 3-dimensional graph. I'm not good at drawing 3 dimensions. I mean, you know, you can kind of imagine like, though it's weaving through this thing, the slope of the income would vary with unemployment. But we usually don't have nice visuals as soon as we go to thinking about the relationship of anything past just our linear kind of one variable. As soon as we introduce 2 continuous variables, it's very hard to get a visual. In fact, maybe you could do a 3-dimensional graph if you're really good at drawing 3-dimensional graphs. It's just a struggle. As soon as I go to 3 variables as my dependent, if I interacted all of those, now I actually have something that I can't even. What have you ever seen a 4-dimensional graph? We see in 3 dimensions. A 4th dimension starts to be things that get to be like YouTube rabbit holes of like time is the 4th dimension, and we're thinking about these. So actually, what you would need there, and I was talking with a colleague the other day. He teaches a higher level econometrics. You actually need something. You need linear algebra to start to think about what these would look like, right? I'm guessing who's taking linear algebra here? A couple people, not everybody, right? So you would actually need to start thinking about things in terms of matrices as opposed to getting a nice kind of visual depiction of it. So with our continuous interaction, what is the visual of the marginal effect? It's really hard to have one, right? So what you would want to think about it conceptually as, if I'm interacting my continuous variables, it's just that the effect of that variable of income is going to be different for different levels of unemployment, right? So it's that the effect of your variable, as soon as you interact it with another continuous variable, the effect of changes in your variable will vary with the level of the variable you interacted it with, right? And we can get a graph or like a table of exactly what that marginal effect would be for different levels of that other variable. But in terms of like, what would the line of best fit look like? We don't have nice visuals for that, right? But, you know, anytime we say marginal effect, all it means is a change in. So the marginal effect of income on your Y variable is just how is that Y variable changing when income changes, right? Now, so it's kind of, you know, it is a slope, but it's a 3-dimensional slope that's harder for us to get a visual on as soon as we go to continuous interactions. Unfortunately, is the answer, right? We can't get as nice, clean visuals as we had when we interacted a continuous variable with a dummy variable. Does that help? Any other questions before we keep? So this should wrap it up for interaction terms. I mentioned I won't give you the next problem set or kind of practice problems until after class Tuesday, because parts of those will include the next thing we're going to talk about, which is the topic of measurement error. Excuse me. I would expect as we progress to the end of this semester, probably more similar things that are a little bit more similar to what we've been doing with the last two topics is where I have like a week or two classes of where we probably work through almost all the slides and we work through those examples, and then a class period where we kind of dive in deeper into a data set. I might try to be finding newer data sets, kind of like I did here, to throw something together that is just another example, rehash these ideas, and me kind of giving you questions, really starting to kind of get you to think about what we're doing with whatever topic we just covered. So we'll get a little bit more time with every single topic. And I'm going to start to focus a little bit more on how we take regression results. So how we run these regressions and use those coefficients to then answer other questions, right? So the problem sets, although you are going to run these regressions, it's probably going to be a little bit more kind of take those regression results and then here's a list of questions, right? You're not going to get as many points for just running the regressions anymore. It's going to be a little bit more run these regressions and then use those results to answer these next couple questions. Okay. Trying to think if there's anything else that I want to say. I think that should cover it for interactions. Are there any questions just about the course, problem sets, due dates, anything that any of you guys have? Okay. Sure. All right. I always get worried when I'm like the one talking a lot. Guys, ask me as many questions as you want. Stop me. Kind of be as interactive as possible. That's going to make this just a lot better for you. It's going to, allow me to kind of answer any questions that I might not have had the foresight to think that you might have, right? Because I come from a different perspective now than what you guys are currently in. And so I probably had the same exact questions you had when I was in your shoes. I can kind of remember some of those, but some of them now I'm getting old enough to where I forget what those initial questions I would have had thinking about these topics. So always feel free to stop me. Like I said, we'll have additional time, a little more extra time. We won't have to move as quick through these topics in the second half of the class. So I by all means, stop me at any point in time. Okay. All right. Once again, kind of that problem set and move the due date to be before we meet in class next Tuesday. Quiz is still due at the end of the day, Friday. Other than that, have a fun, safe weekend. Hopefully the rain holds off, and I will see you guys on Tuesday. Do you have a question, or are you good? Okay.
I should come to the tomorrow.
2:30 if that works.
Okay. I don't know the class.
I mean, if it's a quick question, I can kind of answer it now if you want.
No, that's
okay.
I'll just come back. Also, for the data set, I was thinking like if I wanted to make like sports data sets, like if I wanted to do for NFL, let's say, right? Would I? How do you say go about a regression? Would it mostly be linear, or would it like be very dependent?
Well, it depends on what you want to look for.
If I wanted to compare the QB, like,
yeah.
What sort of data pattern would I do?
So it depends on what you want to know what your question is, right? So what are you wanting to investigate is happening with QBs? Right? Is it a question about their salary, their performance?
Right. So let's say if I wanted to compare salaries, and I probably use like let's say stats like completion rates maybe, and now would I? So the only way for me to actually know would be to see if completion rates just compare R squares by 2 and both linear and non-linear.
That's going to be one thing that'll indicate it to you. Right. You're also going to look at statistical significance of that square term.
Okay.
Right. And we start to dive into things that we didn't cover a ton in class, which is model selection. So you can kind of create F statistics using your R squared.
And another thing I was wondering is, can I use the term of the root MSE as a viable way to compare both models?
Root, your mean squared of the errors.
Yeah. The one where like it just helps you like understand how much errors are there in the variation itself, I think.
You can. It should indicate similar things to you as the adjusted R squared would.
Okay.
But if you're interested, it depends on exactly what models you want to compare. But there are different types of tests you can use for model selection that account for differences in linear versus.
But how does that term help me when I'm building out regressions? The root MSE term, or does that not really contribute much when I'm trying to like look at something?
it's part of the calculation that you would use in getting your statistics like the adjusted R squared.
Okay,
If I remember exactly what stated means by root MSC.
but
But-
I'm talking about the output that appears on the top right, right
Yeah,
underneath.
yeah.
all
Like I said,
square.
I forget exactly what, I'd have to go
Right.
back and look, because like I
Okay.
said, from my memory, some of the statistics it gives you there are just things that are used other places, and I believe that the root MSC, so the root of your mean squared errors is the denominator of your adjusted R squared, I think. So it's just another metric that you have that's already built into the ones that I've kind of mentioned looking at, which is your
But do
adjusted.
people use it? I don't know.
Oh, I'm sure, yeah. Like, especially when you're looking at, like I said, there's all kinds of different model selection tests that we haven't dove into, that some of those statistics we don't talk about, you would use for that.
Okay.
Yep.
Okay, cool, thank you.
Yeah.
Thank you.
I just had a quick question. Tomorrow your office hours, do you have any in the morning? I know you said like 2 o'clock.
So I have a bunch of B251 students who want.
You were saying, yeah.
And so I honestly am like scheduled out